Hey everybody, how's it going? Please mention in the chat if you're doing well. I don't see any participants. Maybe it's going to reflect later. So can I get some confirmation in the chat uh, if you've joined or you've not joined? Yes. Good evening, Akanksha. Yes. Let's wait for the others to join. Yes. Good evening, Chanika. Good evening, Dipti. Yes. Now I can see participants. They're slowly joining. So let's wait for the others to join. How are you guys doing? Yeah, let's wait for the other participants to join. So, syllabus, I'm not sure about that. Probably going to refer to the portal, right? Okay. So, this class, let's maybe discuss about matrices and determinants. Let's solve some practice problems therein. Okay. I hope that works, Kangsha. Let's give another couple of minutes to the other participants. And no one joins in the next 2 minutes, then let's get started, anyways, right? You have any topic to suggest for which you want me to make videos or something in like mathematics? Let's wait for another 1 minute and then we'll get started, all right, with whatever number of participants we have. No, it's not cold here. Where are you located, Dipti? I mean, it is, but it's not as cold as it might be in the north. So it might be in, say, the north of India. So unlike your university where the faculty has to wear formal clothing, this is some casual clothing. So all right, so let's begin anyway. So I'll share my screen and then we can begin. So there's a list of 15 questions, right? A few of them are tough, few of them are medium level, and few of them are high level, right? You're going to solve those questions and give me the right answer. Okay, so let me share my screen. All right, can you guys see my screen? All right, here you go. Perfect. So, first question. What's the order of the matrix A? So when you look at this, right, it basically means like the first row is 2, 3, 1, and the second row is 4, 5, 6. Okay, so 2, 3, 1, and 4, 5, 6. So what's the order of this matrix? You just type the option in the chat. Right, Dipti says B. What about the others? All right, yes. So I think both of you say it's B. Two of you say it's B. That's indeed the right answer. So it has two rows and three columns, so it's 2 by 3, right? Perfect. Next question. So compute A plus B for. So matrix A is 1, 2, 3, 4. So again, it's first row 1, 2, second row 3, 4, and then 4, 3, 2, 1. Compute A plus B. Yes, Deepti is smart. I think she computed the first value and then she found out that it should be between A and C, I guess. Okay, a few more people are joining. That's good. Right. So most of you say A, and that's indeed the correct answer. It's A, okay? Add each corresponding value. Right? Next question. So it's actually should be like both these, right? Identity as well as diagonal. But here, basically, the thing is, a diagonal matrix is like a generalized term, right? That includes both identity matrices. So this answer includes both. Right? So B is the answer. But then even A and B can be both the answers. That's fine. Okay. Next question. So find scalar 3A for A equals 1, 0, minus 2, 4. Okay. All right. So all of you say A, and that's indeed the right answer, right? You're just going to multiply each element by 3. Okay, correct. Next question. All right. So I think this is a fairly easy one. So it's C, 3 by 3, all right? So that's the right answer. Equal rows and columns. Okay, next question. Now compute the product A into B for A and B. Okay, do it carefully. Write it down on your paper and then do the product. All right, so I think most of you think it's A and it's actually A, right? If you multiply rows with columns, that actually gives you the product, right? So this is the right answer. Okay, perfect. Next question. So which condition ensures invertibility? So if you want to invert a matrix, if you want to compute the inverse of a matrix, which is the necessary condition? Chanika, I think you got it. You were earlier giving the another answer, but then you got it. Okay, so most of you say I think it's B, right? That's indeed the right answer, right? So B, determinant of A not is not equal to zero, right? So it should be a non-singular matrix. Okay, only then you can invert it. Next question. Yes, Coco Goa T. What's your full name? Coco Goat. Okay. All right. So most of you got it right. It's 3 into 4 minus 2 into 1, right? So it's 10. That's the right answer. Okay. Perfect. Next question. Okay. Solve for x. Okay, Coco Go is Sid. Okay. Sid what? Okay. Yes, Akanksha Tiwari, you're pretty fast. Right. A couple of you getting the right answers. So it's going to be like, say, 4x minus 6 equals 10, right? So 4x equals 16, which means x equals 4, right? That's the right answer, is A. Okay, cool. Next question. Right. Most of you say A, and that's indeed the right answer, right? So double transpose returns original matrix, right? A transpose transpose is A. Perfect. Next question. Now you got to solve this. Compute the inverse of A. Now, some people might be smart. They might, try another method. So ideally, you should find the inverse. But then, if it's a multiple choice question, you can play some trick, right? What trick is that? Yes. What's the answer? The answer is A, all right? So you compute the inverse using, like, say, adjoint of A divided by determinant of A, right? You can do that, or all you can try to do is that just multiply this matrix by this matrix and try to multiply by all of them. If you get the identity matrix after multiplying this by this one, then that option is the inverse. Correct? Makes sense, everybody? You can try that in the MCQs, right? Just give me a yes if that makes sense. A yes or a thumbs up. Yes, makes sense, guys, what I'm saying? Okay. Next question. Yes, Jenica, thanks for confirming. Yeah, next question. Okay, our conscious is A. Yes, that is the right answer. So if you multiply A into A, you get this, right? 5445. Okay, perfect. So, yes, next question. Here you go. Now find the eigenvalues of 2003. We have just done this earlier. Right? Who wants to solve? The answer is A. Correct answer is A. So the diagonal entry is equal to eigenvalues in case of diagonal matrix, right? Okay. Next. Yes, who wishes to solve for this one? If A is upper triangular, so what is an upper triangular? Like all the values below the diagonals are zero, but all the values above the diagonal are non-zero, right? That's an upper triangular matrix. If A is such a matrix, then determinant of A equals, we have done this, right? We've discussed this in earlier. Coco quote. So you vanished just now, then you came back again. Where were you? Okay. Unfortunately, what you haven't given is not the right answer. Uh, the correct answer is B, right? In an upper triangle matrix, the determinant equals the product of the diagonal values. That's what we had discussed, right? In one of the properties, right? So answer is B. Okay, last question. The system of equations A x equals B has a unique solution if which of the following is true? Yes, who wants to go? First, the right answer is C. A non-zero determinant ensures a unique solution, right? So that's it. I mean, I hope these questions are useful. With this, we basically finish the problem solving for matrices and determinants for this session. I hope the session was useful to you guys. If yes, just give me a thumbs up. And if you want me to share any topic, video on any topic, just let me know in the chat, or maybe just comment on the videos, and then you'll be getting the video as soon as possible. Right. So yes, thanks, Shanika, and thanks everybody for joining. And see you once again in such a live session with another topic. Until then, take care, guys. Bye bye. Right. So in this video, thank you. Thanks for joining.